So we have a formula to find a specific term, and that is a sub n equals a sub 1 times r raised to the power of n minus 1, wherein a sub n is the term to be found, a sub 1 is the first term, n is the number of terms, and r is the common ratio. So it is very important that you need to memorize this formula. Example, given the sequence 4, 8, 16, 32, and so on, find the 15th term. So in order for us to find the 15th term, we need to identify first all the given values. So for a sub 1 is equal to 4, and n is equal to 15. And r, which is the ratio, is equal to 2. So how did we get 2? So that is a sub 2, which is 8, divided by a sub 1, which is 4, is equal to 2. And that is the common ratio. So we need to find the 15th term, or a sub 15, using the general rule for geometric sequence. So a sub 15 is equal to a sub 1, which is 4, times the common ratio, which is 2, raised to the power of 15, which is n minus 1. And a sub 15 equals 4 times 2 raised to the power of 15 minus 1 is equal to 65,536. So how did we get the 15th term? So first, 15 minus 1 is equal to 14. And 2 raised to the power of 14 is equal to 16,384 times 4, that is 65,536. And that is the value of our a sub 15, or the 15th term. Another example, find the 10th term of the sequence 8, 4, 2, and so on. So just like what we did in the previous example, we need to identify first all the given values. So for a sub 1, the value is 8. A sub 1 is equal to 8 for the first term. And for the common ratio, or r, that is 1/2. So how did we get 1/2? That is 4, which is a sub 2, divided by 8, which is a sub 1. And that is 1/2. And n is equal to 10, the number of terms. So to find the value of a sub 10, or the 10th term, we need to use the general rule for geometric sequence, which is a sub n equals a sub 1 times r raised to the power of n minus 1. So a sub 10 is equal to 8, which is the first term, times the quantity of 1/2, which is the common ratio, raised to the power of 10, which is n minus 1. So a sub 10 equals 8 times 1/2 raised to the power of 10 minus 1 is equal to 1 over 64. So how did we get 1 over 64? So that is by simplifying the given equation. 10 minus 1 is equal to 9, and 1/2 raised to the power of 9 is equal to 1 over 512. And 8 times 1 over 512 is equal to 1 over 64. So 1 over 64 is the 10th term of the given sequence. Another example. In a geometric sequence, a sub 1 is equal to negative 2 and r is equal to 3, find a sub 10. So again, just like what we did in the previous example, we need to identify first all the given values. So for a sub 1, that is negative 2, and for r, which is the common ratio, that is positive 3, and n, which is the number of terms, is equal to 10. And we identify the number of terms by identifying the subscript of a sub 10. So what is the subscript of a sub 10? That is the number of terms, which is 10. So again, just like what we did in the previous example, we need to use the general rule for geometric sequence to find the value of 10th term or a sub 10. So a sub 10 is equal to negative 2, which is a sub 1, and times 3, which is the common ratio, raised to the power of 10, which is n minus 1. And a sub 10 equals negative 2 times 3 raised to the power of 10 minus 1 is equal to negative 39,366. So how did we get negative 39,366? So that is by simplifying the given equation. So first, 10 minus 1 is equal to 9. And 3 raised to the power of 9 is equal to 19,683 times negative 2, and that is equal to negative 39,366. And that is the value of the 10th term, or a sub 10.